All right. Quick reminder, I think I mentioned it in class before, but in case I didn't, it is up on Slack, but we know how well this group is at checking Slack. You should do more often. But in any case, next week, Tuesday, Wednesday, Thursday night is our senior seminar presentations. So it'll be down in the collaboratorium outside the makerspace. So these are all the seniors from the CSC491 class that all of you will be taking at some point in your future. These are big projects, 300-hour projects that they've worked on all semester that presumably they'll be putting in front of potential employers as they're applying for jobs now, hopefully having a job offer before they graduate in May. But come and support them by attending some or all. I realize it's a lot of time, but hey, it would be really cool if you came to all of them. At least sat there and worked on homework, whatever, while they were presenting, and paid attention sometimes. But in any case, that'll be next Tuesday, Wednesday, Thursday nights from 5 p.m. until 8 p.m. down outside the makerspace in the business building. Okay, so let's keep cooking here. So we've been talking about building kind of a world, modeling the computer science department, but really thinking about how do we take a real life idea and turning it into a set of objects and things like that. So we decided, hey, the computer science department kind of looks like this, and we want to go ahead and create all of these, we have this thing called a room, and we're going to have some exits, things like that. So we started writing this, and let's kind of see where we left off here. So we've tested this so far. We created a couple of rooms, our entrance and our hall. And then we tested those guys. So an entrance is, or a room, as a reminder, keeps track of a name. It also is going to keep track of an array of exits. So remind me, why is this an exit pointer? Why do I have 2 stars here if this is supposed to be an array of exits? So how is this an array of exits? Good. Okay, so as a starting point, what's an array? Any kind of array is a pointer, right? So if I wanted to have an integer array, I would say int pointer AR. So we would point, the AR would hold a memory address. That memory address would be the base address of that array, the location of the very first bucket of that array. But in this case, I'm holding integers. In this case up here, the type of thing I'm holding is exit pointers. Why an exit pointer? So why am I holding exit pointers inside of an array built for holding exits? What kind of value do we store exits in? We come back out here in main. I built an exit right here, and I stored it inside of a variable of type exit pointer. All right, so objects in C++ are stored as memory addresses, and we need something that knows how to hold a memory address, specifically an address that points to, in this case, an exit. So the type of value that I'm storing is an exit pointer. That is the memory address of an exit. So my collection type here would be an array of exit pointers. That's the kind of animal that I'm building here. Okay. Now we're also going to keep track of the number of exits. Why do I need to keep track of the number of exits when I already have a collection of exits here? Go ahead. Yeah, so in C++, arrays don't know how many values they have in them. In more modern languages, so like next semester, we'll be starting to look at Java, which we could think of as like a C++++. A lot of these problematic type things kind of disappear because Java is a much more modern language, and it said, hey, you know what, this used to kind of suck, so let's fix this, and this other thing wasn't that great either, let's fix that. So even though the underlying reality is still the same, the truths that we're learning in here are still truths in Java, the way that they're implemented is, let's say, better. Java said, you know what, arrays are pretty common things. We might want to have collections of things pretty often. It might be kind of nice to have those collections know how many elements are in them. You know, kind of get a package deal out of it instead of always having to deal with two different things. Here's the pointer to my array, and here's how many things are in there. Let's put those together into one little package and say, hey, why don't you tell me how many things are in there? Same thing's happening under the hood. It's just coming as a package deal. All right. So that's why a room is having to store the name of the room, and then we're going to have our collection of exits, and then a room also needs to know how many exits are in there. So presumably, if we went through all of our exits and we said, you know, I want to show the exits leading out of this room, I think right now, didn't we say the maximum number of exits is a 4? I think we were implementing it in here. So we said max exits is 4. So we were doing this with something called a macro. You could have also just hard coded a 4 in there or something like that, but giving you some sort of global thing that if I wanted to change it, I can change it here. But a macro is different than a variable. It's something that the compiler preprocessor uses to just go through and replace all occurrences of this word with this value. It doesn't have to do a memory lookup after the fact. All right. But the way we accomplish it isn't all that important. But we're saying the maximum number of exits that a room has is 4 because we're operating off this north, south, east, west thing. But if we look back at our picture, not every single room has 4 exits, right? So a room in and of itself has the capability of holding 4 exits, but it's only going to actually have however many exits that room has. This room has 1, this room has 3, this room has 3. This one happens to have 4. All right, makes some sense. So that's why we need to have that variability. So a room knows its name, it knows its collection of exits, and it knows how many exits are filling that collection. All right, so when we first build a room, this is our implementation of our room class. So this just tells us what a room is. Now we're implementing the room. So when we build a room, we need to take in the name of the room. So we set this room's name equal to whatever is passed in. And now we need to go ahead and give ourselves enough memory to hold potentially, in this case, 4 rooms, max exits number of rooms. All right, so we're going to build our memory for that. Now we know that initially, what I call it, number of rooms, number of exits, sorry. What? It's a room. It's a room that has a collection of exits. Gotcha. An exit connects 2 rooms. Gotcha. Yep. Okay. So we're going to have to solve both sides of the problem here. Okay, but right now we're implementing room. So room is going to keep track of a collection of exits, and at any point in time, it's going to know how many exits it has. So when a room first is born, when it first comes into existence, there aren't going to be any exits in there. We haven't added exits to this room yet, right? We just brought a room into existence, and then we're going to go ahead and kind of plop it into wherever it needs to be in our space, and that's where the exits will start coming into play, and we'll start adding exits to a room once we put that puzzle piece in. Okay, so initially there's going to be 0 exits, and then for our, what I call it, the exits, this variable, the exits. So that's going to be my actual array. I need to allocate some memory. So I'm going to allocate some memory. How much memory? That number of things times however big an exit pointer is. All right. And this is going to come out as a void pointer by default. We want it to actually be an exit pointer. Okay. So we're going to memory allocate. We need to know how big an exit pointer is. We'll let the operating system give that back to us, however big a memory address is in this operating system. And we're going to multiply that by whatever max exits is, which is 4 in this case. So if you didn't want to use a macro here like this, you could have just hard coded a 4 in there. In our case here, that wouldn't be the end of the world. I don't anticipate us having this max exits value in 40 different places. But know that if we were going to change it, we would have to change it in all the places that we used it. So the reason that we use either a global variable or a macro like that is so if we did change it, we only have to change it in this one place. We just always refer to it by its name here. All right, so we're going to allocate some memory and make the exits point to or hold that value where that array of exit pointers will live. Currently, there's no exits in there, right? And I've advertised that I'm currently holding 0 exits, but I've given some space capable of holding up to 4 exits. All right. Let's make sure we're still good for the moment. Oh, this was the thing we were talking about at the end of class as well, where a room relies on an exit and an exit relies on a room. So we have this infinite loop type thing built in until it finally finishes screaming at us and say, hey, you know what? I'm done with you. Nested too deeply. You know, it finally just gave up. It kind of rolled with us for a while and then just said, okay, before our computer runs out of memory, let's bail. All right, so we need to have a workaround for this. Notice here that a room includes exit HPP and exit includes room HPP. Now, the only reason we included, it doesn't matter which of the two we look at. So if I'm looking at exit, the only reason I included room HPP here is because an exit holds on to 2 rooms. But this guy right here is just a promise. We don't actually go and use those rooms until we're over here, where we ask a room to display itself, things like that, right? So in reality, we don't actually need to know the details of a room until we're in the CPP file. In here, I just need to know that there will be a thing called a room. A promise that this room thing, this thing I'm claiming will exist here, actually will exist. And I mentioned last class, this is going to be kind of like our prototypes when we prototyped our functions before, letting the compiler know, hey, I'm going to be talking about some stuff here in a few minutes. Trust me, I'll implement it later. It'll be there. All right. By the way, this is another thing that Java fixed for us. C# also fixes for us. So a lot of these little, you know, they're not the end of the world things, but they're kind of like annoying things, right? It's like, oh, why do I really have to do that? Why do I have to do, can't it just do that for me? The answer is yes, but we won't appreciate it unless we had to be annoyed by it now. All right. So what we're going to do is inside the HPP, we're going to prototype that you will see a class called room. I just wrote class space room. Like that's going to be a thing. Nothing else. I'm not going to put anything else in there. And then what I'll do is I'll take the include, the thing that actually brings in the stuff a room really knows how to do. I'll bring that into exit CPP. And what did that do for us? It kept us from having this infinite loop here. As long as we fix it on the other side as well. All right. So we only told exit enough information for it to get past me claiming there's going to be this thing called a room. Similarly, I'm only going to give, so in room right now, we're including exit HPP. Why? Because this guy needs to know about exits. So now I'm only going to give him enough information for him to know that there's going to be a thing named exit. Trust me, there's going to be something called exit. And now in room CPP, that's where I'll actually include it. So now it's no longer creating the loop, because room HPP does not include exit HPP. Room HPP just kind of starts the conversation and says, there's gonna be an exit. Trust me. Make sense? So see how it's kind of a lot like our prototyping that we did before? Still annoying, right? Yeah, this still isn't necessarily the most straightforward thing. It seems like that's something that the compiler maybe could have figured out on its own, which is a true statement in some of our more modern languages. Our more modern languages like Java and C#, they handle this through things called packages and namespaces, which is a fancy way of saying stuff that's in your current directory. They just know to go and check there before it starts freaking out. Where in C++, you kind of have to, that's where the double quote stuff comes in, saying, yeah, look for this in the current directory, instead of it just saying, why don't you just check for yourself? Not the end of the world, but that's how this older language worked. All right, so room, we're going to tell them about exit, but we won't tell them the details of it. Room CPP, this is when he gets the details. Because presumably down here, he might start using those exits. Like we presume that we're probably, when we're doing the obvious exit thing here, we're probably going to be using the exits, the array of exits that we have. We're not right now, we're just foreshadowing it, but we will be using it. All right. Similarly, in exit, we're going to tell him enough information to know about rooms so we can get, he doesn't scream here, but not until exit CPP will we actually give him the details of what a room actually is, so that when we start asking rooms to do things, it has the basis covered. Make sense? Where is this guy? This is a main CPP. He did ask. I didn't just offend him. He told me he was going like, I'm done with this. Later. So now I can include room HPP in here. Okay, that was the macro thing, and he didn't like that. So it's not liking my max exits. I told you last time I wasn't 100% positive on the syntax for macros. You know what? Just so we don't have to spend time on this, I'm just going to do this. Give ourselves a global variable of type int called max exits, and it's going to be equal to 4. There is a thing called const that means you can't change it, but it doesn't make any difference. That's not what we're focusing on right here. So I'll just define a variable whose scope is everywhere in here so that whenever I say max exits, it has access to it. All right. So not screaming anymore. So presumably we've cleared all our hurdles. We don't have the infinite loop of our header files anymore, things like that. All right. So before we go any further, are there any questions about this solution we have for this nested header file thing? Go ahead. Sure. Go ahead. Because we're using the, well, so I guess the short answer is yes. But it's because of the syntax thing difference here. I believe I could have written it, and this has to do more with, I don't know what to trust with what this guy knows. What she maybe would want it to look like is I want to create a new exit array of size max exits. Something like that. And that looks way friendlier. Something like that. Maybe we'd actually throw it's an exit pointer array thing in there. That seems way friendlier. And if you were writing this in Java, that's how you would write it. You would write it with in fact, you wouldn't even have the pointer piece in there. So I guess first of all, I'm not even confident it's going to be cool with this. In fact, I'm fairly confident it won't be. Well, I'm still not 100% confident he's still cool with it. Let's be honest here. We can roll with it if you want and just see what happens. But I personally like this thing from it goes hand in hand with what I try to do in here. It's that I want to show you like what's really under the hood so that eventually when you don't have to deal with that crap anymore, you kind of feel like, yeah, this is nice. It's kind of like you're in first class of the airplane instead of riding on the wing. All right, go ahead. There really isn't a difference. So the new keyword and malloc do the same thing. They go out and find memory. The difference here is that when I use this syntax, my presumption is that the new keyword is going to figure out how much memory I'm asking for by what I have right there, where I have to be more explicit here. So malloc is older than new. So this guy needed me to tell him exactly how many bytes of memory I'm asking him to go find. Go find me 13 acres of land specifically, instead of telling the real estate agent, I need enough land to hold this house and having them figure it out. But ultimately they're doing the same thing. Malloc finds this much memory. New finds this much memory, where this much is however much memory that takes to hold. Go ahead. Oh, yeah. So he's asking, why don't I have to take other parameters up here, right? Well, did I need any parameters to know this guy should be a 0? Did I need to pass in a 0, or do I just know that I currently, when this guy's first born, I don't have any? So really the question you're asking is, do all constructors have to take in all the fields? Okay, so, and that's the good question. He's like, well, why didn't you also then take in int number of exits, and then also potentially take in the exit pointer, the exits, something like that? Why didn't your constructor take all 3 of these things? Well, first of all, why didn't we take this last one? Because we probably didn't want to have to build that externally. We want our constructor here. The job of the constructor is to initialize an object. Okay, so when a room first comes into existence, so we'll pretend like this is a room. Okay, so poof, this room comes into existence. Right now, I can just say this guy has no exits attached to it, and we can make that presumption internally that he just was born. No exits have been hooked up yet, because my intention is that I'm going to connect some exits here in a few minutes. Okay, but similarly, I can say, well, he probably has space allotted or allocated for some exits. If I don't have the constructor do that, instead I have to give him that information, then I would say, room, I want you to create a room called entrance, and you're going to have 0 exits to begin with. And presumably then every single time I ever create a room, I give it a 0 for that, right? So if you find that you're always giving it the exact same value every single time you create it, chances are you didn't need to pass it in. You could have made the presumption of that internally. Similarly, I would have had to externally create his collection of exits and say, okay, this is where you should put your exits later on when you when you actually get them. Where we could just rely on the room to handle all that internally and just say, hey, You're born, you're now in charge of taking care of yourself. What did I have to actually give you for you to work? All he needed was a name. The rest of it, he kind of already knew how to initialize himself internally. So the answer is that just because in room HPP, we happen to have 3 fields, your constructor does not need to take in all 3 fields. It doesn't have to take in any of them. No, just because the job of the constructor is to initialize this guy to whatever we want it to be. I didn't have to use, so if I take this out here, I could choose just to set this guy's room name to LOL, regardless of what you passed me. I didn't have to use it. So if I was just going to have all my rooms start off being named LOL, I could choose not to take any parameters here if I didn't want to. And also, nothing requires me to initialize any variables. If I don't want my constructor to do anything, I don't have to make it do anything. It stops making logical sense if the purpose of the constructor is to initialize a room, and I decide that it's okay for a room to be born with nothing. I mean, yes, he has a name, he has a number of exits, he has a memory for those exits or a variable for holding the exits, but I didn't set it to anything. So right now he's this empty husk. Literally, I wasted my time with the constructor other than fulfilling my requirement of having a constructor. So the bottom line is, when you go and build an object, the constructor's job is to initialize that object in whatever way you think is most appropriate for initializing it. And in this case, we might say, you know, I probably only need you to give me the name, because that's the thing that's going to vary as you build multiple rooms. You're going to have different room names, but every room when it first comes into existence is going to have a number of exits that starts off at 0. And every room that comes into existence is going to have some memory for storing future exits up to max number of exits. So I already have that information internally. I don't need anybody to give that to me externally. All right, other questions? Go ahead. Yeah, you can always change it to whatever you want, but
the default value of constructing LOL. And I say at some other point, room.
Sure.
I have the parameter say room.
Yep. But as of right now, since even though I'm taking in a name, both of my rooms are called LOL.
Oh, so that the default value overrides.
I never used it. So even though out here I passed it the string entrance and I passed it the string hall 1, in my constructor, I just ignore the fact that you gave me anything. And I just always set it to LOL.
Then how do you set it to the default? If I just say, give me a room that it's default in the LOL. But when I say, give me a room called.
So are you asking, how do you have a constructor that allows them to not pass it a room name if they wanted to? This is something that actually isn't allowed in a lot of our more modern languages, but you can say string name is equal to LOL up here like that, so that if they don't give you something, I think this is the syntax for it. So I'll just happen to not give that guy a input. Doesn't like that. Yeah, he doesn't like that I didn't give him a value because I've advertised I would. That would work in C functions. But I would say that's would be pretty bad programming practice anyways. Old school functions, you can have default values for things that are omitted, but I would still say that's bad programming practice. If you write a function that's asking for you to give it 2 inputs, give it 2 inputs.
If they do effectively the same thing, I miss the part where you said
Because I'm not sure which historical version of the C++ compiler this guy is.
Okay.
Yeah. Okay. Basically, in any modern language, the syntax you'd use for creating arrays is going to be pretty close to this guy. Yeah. Like in Java, if I was creating this, it would be new exit without the little asterisk on it, and then however many I wanted. 100% that would work. So the older we get, the least consistent this might get, especially since we're using this web-based one, where I know malloc will work because I'm not having to play the syntax game. I'm just saying when I call malloc, I just tell it the number of bytes I need. So I'm doing the math in there and letting it figure it out. Go ahead.
Why don't we set the default variable to 1? If we know that there's always gonna have to be at least 1.
Well, because we know that there's always going to have to be at least one, but we might have 4. So if we set it to 1, so he's suggesting why don't we set it to 1 here?
Not the matrix, just the number.
Still same. It's the same thing, whether I put a 1 in here or not, right? Oh, or you're saying this. Why don't I set it to 1 there?
Yeah.
Because I don't have 1 yet. I mean, I get what you're saying. You're saying, well, if I know there will be at least 1, why can't I set it to 1 yet? The idea is that the number of exits that we have, I'm initializing a room. So when this room is currently born, even though I might know that this guy will eventually have at least 1 exit, right now he has 0. He doesn't have any exits. I've given him enough land to throw up to 4 in there, but the current exit count is 0. We haven't added any yet. We'll be adding some shortly, but we have to kind of put our mindset into this guy was just born. What is the initial state of a room as soon as he comes into existence, even though I might be doing some manipulation with them shortly. Right, makes some sense? All right. I thought you were asking the other question of why don't we just create enough memory for 1? Well, then the idea is, well, what if you have more than 1? If you have more than 1, now you're going to have to go and destroy the old memory and make it a little bit bigger to give yourself enough memory to hold everything up front. Good.
So kind of going off that same stuff, can you create multiple constructors that take in different?
Yeah, you could have, so if you wanted to have, and let's go ahead and just do it. So he said, hey, what if I want a constructor that takes nothing as a parameter like this? And then I go ahead and write this constructor. And I say this name is equal to LOL. So now I have 2 different ways I can build rooms. I can build a room passing it no inputs and just having it set the name to LOL. I can also pass it a name and have it set the name to whatever you passed in. So now when I go and use it here, if I chose not to pass in a string here, this entrance was built using one of the constructors. This room was built using the other constructor. So there's our LOL and our hall1. So you can choose to have different constructors just like in real life. You know, if you're building a house, you might find one person who you just hand them a giant wad of cash and he'll build you a house. Another person, maybe you give them less cash, but you also give them a bunch of building materials and things like that. And, you know, so you're giving him some of the stuff he'll need and then some money to get the rest of the stuff he needs. So in that case, we have 2 different constructors for building a house. One that takes just a bunch of money, the other one that takes money plus 2 or 3 other things, something like that. All right. Well, actually, let me keep going down that line because it's a good example thing here. Realistically, if I have 2 different constructors here, I still would want to set my number of exits to 0 and give myself my memory for my max exits, right? Whether I'm building a room with no name or I'm building a room with a given name, I'm still going to set number of exits equal to something and give myself my memory for my exits. That's part of what it means to initialize a room. We've decided that A room in its initial state has a name, one way or another, it has a name. Either you gave it to it or I just made one up for you, hard coded it to LOL. But it also is going to have an initial value for number of exits and an initial memory address to hold those future exits. So when I look at something like this, I have two separate constructors, but notice that several lines in here are identical between the two of them. This would be, now this is fairly small number of lines of code, so not the end of the world, but this would be generally thought of as bad programming practice. You shouldn't repeat code if you don't have to. So really what I would probably do in this case is I'd probably have a function maybe called void init memory for exits. Something like that. And I'll make that guy private so it's only accessible inside the object. And then inside of room CPP, I would go ahead and put those lines of code there. And then I could call it from there. And I can call it from there. So I'll write the code for initializing memory for exits one time, and then I'll have both constructors call upon that guy. If I, in fact, did have two separate constructors, so maybe we call this guy no name or something like that, in the event that somebody creates a room that doesn't have a name, not that we intend for that to happen, but we've created the ability for you to create a room without a name right now, just cause. Okay. So if you did have two different ways of creating rooms, you still need to initialize your memory. And if you're going to do that the same way, regardless of whether the room had a given name or a default name, you probably want to write that code one time and then put that logic in there and then just call upon that from within your constructor. And note that I've put it in the private section here, which means it's only accessible inside the class called room. Because I don't intend for my folks out here in Maine to call to say hall 1. I don't intend for that to be allowed. Even though init memory for exits belongs to room, because it's a private member of room, it's only accessible from within the room class. Out here in Maine, I'm not in the room class. But in the implementation of room, right here, I am in the room class. I am in the room class. So this is how you can give yourself a kind of a private ability internally that's used by other parts of your class, but still hide it from external. That's that idea of what's an object. You know, our example of the procedural telephone versus the object-oriented telephone. The procedural telephone is a giant pile of wires with all the details exposed. Object-oriented telephone stuffs all those wires in here, but only pokes holes for the public interfaces, the aspects of it that we actually need to interface with. So what I'm saying is outside in Maine, I don't actually need to do that. Only inside of the constructor for room did we need access to that. So these are a couple of wires inside that just happen to be plugged into each other. So this would be illegal right now because I've made that guy private. But if I made it public, I'd be able to do it. But my intention is only to use it inside of the room class. Therefore, I made the security settings on it as tight as possible, and I don't have to loosen the reins at all to use it externally. Go ahead. Yeah, well, well, not even jumping ahead, because friend is in Java, the equivalent of that is called package level. So there's four different security settings. There's public, private, protected, and in C++ something called friend. So friend basically says, are you in the same directory? You can give it to anything in the same directory, where public means it's accessible anywhere that can read from this directory. So really right now we're thinking of public as kind of the same thing as what friend actually is, because our whole code, our program lives in the same folder, right? So when we say make something public, we're really saying that I want to be able to access this by my other code that I've written in this same folder. So functionally, the security thing for friend would be the same thing. I would say that's not something you would commonly use, even if we go to more modern languages like Java. The default security for Java, if you don't set something as public, private, or protected, the default is package level security, which is effectively friend, which only allows things to access it that are in the same package. And in Java, packages are managed just by the directory structure, unless you specify the name of the package in there. So unimportant for us. I would just keep our mental world right now sitting between public and private. It's either only accessible inside the class or it's accessible outside the class. You have more? Okay. So we have a couple different ways of building building rooms if we wanted to take advantage of them. Right now, that's a funny error. Yeah, telling me this guy's private. I wonder what that error was. Like, look, here's a number. Deal. All right, so now it's giving me a reasonable error. I made the init memory for exits. I made it private. I'm trying to access it from somewhere outside of the class in which it was defined as private. Not allowed. Okay. And that's good, because that's why I made it private. Okay. So now, and I'm not, yeah, this is our exit 0 display thing right now. All right. So now I've taught my rooms how to give themselves a name and enough memory to hold their exits, presumably, with a little bit of an asterisk right here as whether or not this is going to work. I'm actually surprised it's compiling. So my guess is it probably will work as of right now. Because I'm with you. This is a significantly friendlier syntax. Okay. But from a computer science perspective, this is actually the more logical syntax, because you're saying, I need some memory. This is the number of bytes of memory I need. I mean, you could have just put 300 in there and say, I need 300 bytes of memory. Doesn't matter why, but I need 300 bytes of memory. Okay. So now a room exists. So now when we go to build an exit, when we created our exit took in 2 rooms, and then the directions, I think we decided the direction leading to that room. So the direction A was the direction that one would take in order to get to room A. Direction B was the direction one would take to get to room B. So not only am I going to initialize those parameters, then I need to let each room know about this exit we just built, right? Because rooms hold collections of exits. An exit holds a link between 2 rooms, right? So I have 2 separate rooms. Now I'm building an exit that says, okay, you're room A, you're room B. But now I need to let room A know about this exit, and I need to let room B know about this exit. So the exit knows about room A, the exit knows about room B, room A also knows about the exit, which knows about room A and room B. Room B also knows about the exit that knows about room A and room B. All right, so we just have 3 pointers floating around: a pointer for room A, a pointer for room B, and a pointer for the exit. room A knows about the exit pointer, room B knows about the exit pointer. The exit knows about both the pointer for room A and the pointer for room B. These are just memory addresses. It knows where it can find all those things. Go ahead. Let's see how I built it. If I'm in entrance, when I build my exit, to go to entrance, is it from entrance to the south? This isn't a code thing. This is just how we want to represent it thing. So to get to entrance, I need to head to the south. Yeah, that's the direction we would go to get to entrance. So to get to entrance, I would go to the south. To get to hall 1, I would go to the north. And that's just the decision we made. You know, we could flip that around if we wanted to make it something else. We could also just make it random. Just say, hey, choose your own adventure map and let's see what happens. Okay, so inside my constructor for exit, the exit's being set up here, but now I need to let rooms know about this exit. So inside of room, I need to have the ability to add an exit. And in order to add an exit, I'm going to take in an exit pointer and exit. All right, so we are teaching a room object, this guy that we just created. I'm saying, okay, you were originally created with a name and the ability to hold exits, but right now you don't have any exits. So now I'm going to teach you how to allow somebody to give you an exit to add to your collection of exits. Make sense what we're doing? All right, I'm just giving this guy another ability, and I'm going to call it add exit. So this is inside of room. I'm teaching a room how to add an exit. Okay, now what does it mean to add an exit to a room? What do I need to accomplish from an implementation perspective? I'm not asking for the code yet, but what does it mean for a room to add an exit? What must occur? Good. A room here already has a way of knowing how many exits he has. So let's just start with that. So if I add an exit, what happens to the number of exits? Goes up by 1, right? If I used to have 0 exits and you just added an exit, now I have 1 exit. Okay, so one thing I need to do is I need to increase my number of exits. Secondarily, the exit you just gave me, I got to put it somewhere. Where do I put exits? Go ahead. In my array, right? So I have this place called the exits that presumably, hopefully, we gave correct memory for this guy. So I want to stuff it in there. Okay. So since this is my very first exit I'm adding in our example here, I'm adding an exit. I'm going to add it to bucket 0. If it was the second one, I'd add it to bucket 1. If it was the third one, I'd add it to bucket 2, so on and so forth. So inside of add exit, I'll say this, the exits at bucket, this number of exits is equal to an exit. So remember, originally, number of exits was 0. So the very first time I call add exit, I'm setting the exits at bucket 0 equal to whatever exit was passed in. And then I need to remember to increment my number of exits. So for the very first time, you gave me an exit to add. I added it to bucket 0, incremented my number of exits to 1. The next time you call this, I'll add it to bucket 1. I'll increment my number of exits to 2, so on and so forth. Go ahead. Yeah, I'm not allocating new memory.
But you've already said define as much memory as you want, and that is bucket 0. And then
It's 4 in our case times the size of a pointer. So I've created enough land to hold up to 4 of these guys. I haven't put anything on that land yet. This is where I'm actually putting it on that land. All right. So my constructor, I gave myself some space for my up to 4 exits, but not until I actually add an exit do I put that exit at one of those places in memory that I had already previously built the space. Go ahead. Correct. That's the reason we built the memory. Yeah. So the reason we did this init memory for exits is as part of our constructor, we said, you know what, when a room is first built, he currently has no exits, but we're going to go ahead and give him the ability, the land ability to hold up to 4 exits. Okay, this would be similar to like you're buying some real estate outside and you're like, you know what, initially I'm gonna build a small house on it, but I want to have the ability to maybe put up 3 barns later when I have more money to afford them or I have a need for them, something like that. So you might choose to buy enough land to grow into, but you don't actually fill it with that stuff yet, but you still have the land. You're preventing your neighbor from using it because you've paid for it, you've allocated it. Okay, so we allocated all the memory we might need up here. Now we're starting to use it. So we're adding an exit to the land we already allocated. And then we're remembering that we just added another exit. That's when we increment it by 1. Okay. So that's how we add an exit. So now we've given a room the ability to have an exit added to it. Now the question is when does a room have an exit added to it? When do we actually tell that room to add the exit? We draw our picture here. Steal those 2. Actually, let's steal these guys. I'll make this a little bit bigger for my example right now. What did I call it out here? I called it exit 0. So that guy's exit 0. And that's the exit I built. And then I have hall 1 and entrance. Okay. So these are the objects that exist right now, right? Now, right now, exit happens to hold on to, and let's just so we can, we're going to say this guy is memory address 100, just to keep it simple. This guy just happened to be at memory address 200. And this guy just happens to be at memory address 300. I'm putting that little 0x beforehand. That's kind of nomenclature for hexadecimal. It's a hexadecimal address, but this is address 100, address 200, address 300. These are the places in memory where these 3 objects live. These are the pointers. All right, everybody's good with that? So what kinds of stuff does an exit hold on to? An exit holds on to a pointer to the first room and a pointer to the second room along with some strings. Okay, we'll forget about the strings for a second. So exit 0 is going to have access, is going to hold locally 2 pointers. Pointers in memory that get it to the places where the rooms it links are. All right, so this object right now, this guy himself lives at 300, but he's aware of 100 and 200. He doesn't have hall 1 stored inside of him. Instead, he has a pointer that gets you to hall 1 stored there. He has a pointer that gets you to entrance stored there. All right, so if I look at the state of exit here, exit was brought into existence right here. I built this guy by passing it pointers to 2 rooms. And what did he do with those pointers? He remembered them. Make sense? So exit 0 lives at a certain place in memory himself, but he's remembering 2 other places in memory. That is the location of the rooms that he connects. Now, we want rooms to know about their exits. So hall 1 should know that he's involved at some level with exit 300. The exit lives at memory address 300. So he should know about that. We also want entrance to know about that. So exit 0 knows about 2 different rooms, where hall 1 knows about 1 exit. In this case, we've only created 1, and entrance knows about 1 exit. But each of those are capable of knowing about up to 4 exits, right? So right now, this is already a thing in our code. We built exits with the ability to remember the addresses of 2 rooms. But now I need to figure out, and now we've taught rooms how we can add an exit to them. Now the question is at what point am I prepared to let this room know about this exit? Well, we could do it after the fact. So we could, here in main, after we've created the exit, we could say hall 1, add exit, exit 0. Similarly, we could say entrance, add exit, exit 0. So I could do that, right? Main's starting to get a little cluttered though. So I could externally do this, but would I have an opportunity before this to let my rooms that are involved in this exit know about the exit? When I'm in the middle of building this exit, I already have the 2 rooms in here in the constructor for this guy that should know about the exit I'm in the middle of building, correct? How do I let room A know about the exit I'm currently building? So if I say this, room A, add exit, and I say this, room B, add exit, what do I fill in for the question mark there? How do I let room A know about the exit that I'm in the middle of building? And how do I let room B know about the exit I'm in the middle of the building? Good. No. Recursion is when a function calls itself from within itself. And you have all the information you need to answer this. But hopefully this closes the loop on something that's a little bit hard to understand. So what do I replace those question marks with? how do I let room A know about the exit? Because right now I'm in the constructor for exit, correct? Okay, because the constructor for exit is how exits are built. So I'm in the middle of creating an exit. And this exit already exists. I'm just filling out its variables, right? And I want to let room A know about this exit. Go ahead. You want to say this arrow exit like that? What's the exit name? Is it? Do I have a variable in here that I have access to in the scope of this guy called exit 0? No, finishing answering your question. You're right on the cusp. You're at the door of the problem. Go ahead. Exit with a capital E, but still with a 0? This guy? Do you see him floating around anywhere in here in this scope? Go ahead. Why would you think it's, so you want to just say this? Well, why would that work? So what's this? So this is how an object refers to itself from within itself. So I'm in the middle of creating an exit. So this would be the current exit I'm in the middle of creating. So if I were to print out the value of this, I'd get some memory address. By our picture, the value of this in this constructor would be 300, right? So I can let room A know about this exit by just passing him a pointer to myself. I can let room B know about this exit by passing him a pointer to myself. This is how an object refers to himself from within himself. The reason we need that is for the exact reason that you wanted to put exit 0 in there. You wanted to talk about the exit we just built. We're in the middle of building, but you don't have access to that variable from in there. You only have access to that variable in main. So if you're inside the constructor for this guy, the only way you can talk about yourself is with the keyword this. Room A, I want to add an exit to you. What exit? Me. The exit I'm in the middle of building. Room B, I want to add an exit to you. What exit? This. Make sense? Okay. So inside, we're just going to prove a point here. Inside of add exit, I'm going to go ahead and say an exit display. We'll just prove that this keyword that was passed in is in fact the exit that we were in the middle of building. So if I look at main here, I'm building a room, I'm building another room, then I'm building an exit in terms of those two rooms, but inside of that constructor for exit, I let each of those rooms know about the exit we were just building. And rooms add exit tells that exit to display itself. So if the correct value is being passed in, I should see the information about this exit displayed to the screen twice because each room becomes aware of the exit. Make sense? So there's the 2 times. This is the first time. This is the second time. This is the output of what an exit looks like. All right. Makes some sense? All right. So now, going back to a room, we have this display function here in this room. And as of right now, we just have the phrase obvious exits there. Really what I want to be able to do is I'm just going to go into exit for a minute here. Actually, I'm going to go into room and I'm going to have it not display the exit anymore. I don't want that extra output now. So now the output of my program should be nothing. I'm doing a bunch of stuff, but I'm not actually displaying anything yet. So I want to say entrance display hall 1 display. And rather than it stop at obvious exits, I want exits. I want entrance to say there's an exit to the north for obvious exits. So I want my output in this particular case so, for example, from entrance, we should see an obvious exit to the north. From hall 1, we should see an obvious exit to the south. That's what we want our output to be right now. We don't have the ability to take exits yet because we don't have anybody to take the exit. We look at our picture here. We got rooms, we got exits, but we don't got people. We got nobody to wander in and out of exits yet, right? So for our homework, we want to update our display method for room so that it goes through all of the possible exits that there are, displaying the direction of any exit that doesn't lead to us. Because I don't want to say that entrance has an exit to the north as well as an exit to the south, when that south exit was the exit that one would take to get to us. So from the perspective of if I'm standing in the room entrance, if I'm standing here, the only door that I would see in that room is to the north. If I'm standing in hall 1, well, in this picture, you would see to the south, to the east, and the west. But as far as what we've built so far, the only entrance that we would see is to the south. Now, we could build out these other rooms and build these couple of exits. So I can go and, so I need a hall 0 and a hall 2. All right, we already built exit 0 here. Now let's build exit 1. We'll say this guy is exit 1. So exit 1 has east heading to hall 1, west heading to hall 0. Hall 1 to the east, hall 0 to the west. Hall 1 to the east. From this exit's perspective, if I travel to the east, I end up at hall 1. From this exit's perspective, if I travel to the west, I end up at hall 0. Hall 1, hall 0. Now we'll build exit 2. This will be exit 2 right here. If I travel to the east, I'm at hall 2. If I travel to the west, I'm at hall 1. East, I'm at hall 2. Hall 2 to the east. West, I'm at hall 1. Hall 1 to the west. Okay. So for these guys right here, what I should see right now is entrance should show an exit to the north. Hall 1 should show an exit to the west, the south, and the east. It doesn't really matter what order you have those in there. So don't worry about the order of west, south, and east, but those are the 3 exits you would find if you're in hall 1. That makes sense? So your homework is to update the display method for room to work for this. And the current program that I have, I'm asking entrance and hall 1 to display themselves. So this is roughly the output you should get. Maybe these guys are in a little bit different order. So right now, that's what it shows. Save this. Share this. You have this as your starting point. All right, and that will be due on Tuesday. Question what I'm asking you to do. So most of this is pretty easy as long as you understand everything we've got to this point. You're not gonna have to write a whole lot of code. Okay, you need to make sure you understand what we've done. So you might have to go back and review this a little bit. All right, I will see everybody on Tuesday.